Hello, today we're doing Pythagoras' theorem. I've got Benny on camera and we've got a sort of cradle set up to help us so we don't wobble too much. If you plug it in, Benny. Okay, Pythagoras' theorem is a way of finding out lengths of sides in right angle triangles. So if I draw one, a right angle triangle has one angle which is 90 degrees. And in Pythagoras' theorem, it states that a squared plus b squared equals c squared. Now c in a right angle triangle, when we're using Pythagoras' theorem, has to be the hypotenuse, which is the long side opposite the right angle. So this has to be c. So this is a and this is b. These two, it doesn't matter which way round they are, but this one has to be c. So for example, if I had this triangle had this length here was 12 centimetres and this length here was 5 centimetres. To find out the length of C, I could use Pythagoras' theorem because it's a right angle triangle. So I could say a squared, which is going to be 12 squared, plus b squared, which is going to be 5 squared, will be equal to c squared. Well, we don't know that, so we just keep it as c squared. So 12 times 12 equals 144. So that is 144. Plus 5 times 5 equals 25. So that is 25 equals c squared. If I add those together, so c squared will equal 144 plus 25, which equals 169. So c squared equals 169. So to find out what c is, to unsquare that, I need to find the square root of 169. Now, on my calculator, there's a square root button there. If I type in 169, it'll give me 13. So that means that 13 times 13 would equal 169. So C equals 13. Centimetres. Okay, I'll do another one. I'll draw another triangle here. Hopefully you can see it. I'm a bit worried about where the camera's positioned. We'll see how it works out. Okay. So we'll say that this is 6 centimetres and this is 4.5 centimetres. And this is our right angle triangle. So to find out where C is, we go opposite our right angle. So this has to be C. This could be A and this could be B. It doesn't matter which way round they are. They could be either way round. So using Pythagoras' theorem, A squared, so in this case 6 squared, plus B squared, which is 4.5 squared, will equal C squared. Well, 6 times 6 is 36, plus 4.5 times 4.5 equals 20.25 equals C squared. 36 plus 20.25 equals, I'm just working out at the side, I don't know if you can see that bit, so c squared equals 56.25. I just added those together over on the right hand side. So to find out what c is, I square root this number. So again, on my calculator, I put the square root button and it's 56.25, which equals 7.5. So C equals 7.5 centimetres. So what we're doing is we're doing A squared plus B squared equals C squared. So whatever this number is, 6 squared plus 4.5 squared equals C squared. And once we found out what C squared is equal to, we then square root that to find out what C is equal to. Sometimes you're not given A or B, but you're given C instead. So if I draw one there, I'm still worried you're not seeing the triangle. Let's see. So again, here's my right angle. So this angle is 90 degrees. Opposite side of that has to be C. And then this side length is going to be 4. This side length is going to be, this side length is 5. And we're going to find out this side length here. So I'll call that B and I'll call this A. So we've got A squared. So in this case, it's 4 squared. Plus, we don't know B, so we're going to keep that as B squared. Equals, well, this time we know C, because we know it's C is 5, so C squared is going to be 5 times 5, or 5 5s are 25. Now, thinking back to our tutorial the other day when we had equations, we solved them by moving all the numbers over to the right-hand side and all the one thing we don't know to the left-hand side. Well, in this case, we don't know B, so we're going to move our numbers over to the other side. So we're going to take off 4 squared. So we're left with minus 4 squared, minus 4 squared. So B squared equals 25 minus 4 4s are 16. So B squared equals, Ben, do you want to tell me what 25 minus 16 is?
9.
Well done. So what will B equal?
3.
Well done. Really nice. So that means that this length here is 3. So this time we had to do it slightly differently. We had to rearrange our equation to find out what B was. So we did 4 squared plus B squared equals 5 squared. And we had to rearrange it to get B on its own. And then we had to square root the answer. I'll do one more like that. .6 centimetres, and this one we don't know. I'm going to call that B, and this one is 20 centimetres. Now this is our right angle here. So this side has to be C again because it's the hypotenuse. So this one we call A. So we've got A squared, so 9.6 squared, plus B squared, we don't know, so we'll keep it as B squared, equals C squared, where we're told that C squared is 20, or C is 20, so C squared will equal 20 squared. So I'll do this one on my calculator. 9.6 squared is equal to 92.16 plus B squared equals, well, 20 squared is 20 times 20, so 2 2s are 4. 20 times 2 would be 40, so 20 times 20 would be 400. So B squared equals 400 minus 92.16. So B squared equals 307.84. And to find out what B is, we just square root that. So on our calculator, square root, and we end up with B is equal to 17.5. I've just rounded it to 1 decimal place, which doesn't look very clear there. That's a dp, decimal place. And that is Pythagoras' theorem.
Bye.